this started. Let's see what's going on today. Happy Tuesday. I'm gonna just be doing a little quick code sesh today. I gotta go at 9, so I'm gonna go till about 9 or so. And let's see, I gotta finish up. Okay, yeah, see, the thing I'm gonna work on today is this. Well, two things. So the other day I was working on going through this, the PostGIS tutorial. Let's see, where's that? Is that it? Yeah. I was working on this PostGIS tutorial as sort of a way to test out, oh no, I hosed something up. That's bad. Oh God, I have to fix this. All right. Let me see if I can get this started. I gotta recover from what I was working on the other day. Let's see. I gotta clean out, man, I really need to clean out my Git branches in here. Let's see. Oh man, the music is getting on me here. All right, messing around with some music a second there. Yeah, okay, so I was working on this the other day as like a test case for my BigQuery integration, and just found like a few kind of UX things that I thought could be improved. In particular, there was a lot of stuff I was missing around how I was not yet handling like JSON properties in a robust way. Because as a first pass, I just stringified everything, and so let me pull this up. BigQuery, yeah. So if you look in here at my stuff that I was dumping out, where's the tutorial? Yeah, you'll see that all these tables they have like properties dot blah, and everything's just a string because I just did that. And so I've been working on trying to support having those as like real JSON values, numbers. I think I'm just gonna do numbers, booleans. I guess null, obviously, for now. I'm probably going to skip worrying too much about arrays and stuff. But yeah, trying to get that going. What do we got going on here? Oh yeah, so then the other thing that I'm trying to recover from here, because I've been experimenting with some different ways of messing around with Google Container Registry and trying to speed up my cloud build, but I think I didn't really get that far with it, and in fact, it looks like I've somehow managed to hose up the CSS on the app as part of it, which is kind of hilarious. So I got to deal with that real quick. I'm just going to actually just ditch that for now. Let me see, what's the history on this? Yeah, screw this. Do you see? Let's just go back to master. Yeah, okay, I think that's all right. Let's just get this going. There we go. Is that running? Oh, it's compiling. Compile. Man, it is really compiling hard. 64% over there on that CPU. There we go. Let's see if I have assets locally. Yeah, okay, locally I have assets. That's cool. That's enough for now. I guess no one's using it in prod anyway, so I'll deploy that again later and get that fixed up. Okay, so I'm going to go ahead and let's make a branch. Let's see, do I have a branch JSON? Oh yeah, JSON props do I have? Maybe this is what I've been working on actually. God. This is like if you go away for 2 days. Oh yeah, support full JSON props. This is what I was working on. Good. Okay, that's where I want to be. So that's good. Oh, coffee time. Get a little compiler break here. Okay, there we go. There's some data loading. Oh yeah, so part of what I had done here is I got this, before I used to only support strings as part of this, and so I sort of, well, this is not a good example because they have to be stringified in the tile generator, but outside of the tile generator, let me see if I can zoom in on here. Oh wait, I want to do default. Yeah, so I got this, I sort of made some schema changes so these can actually support JSON. So here's like a string, an array, I guess another array. And it was tricky to figure out how to manage this interface. This is some stuff I worked on like off stream, but basically like if you come in here and if you type something that's not JSON, it will turn it into a string. Whereas if I type something that is JSON, it'll parse it and be okay. So that's how I get, one way you can get actual JSON data in. So now what we got to do is get that into the BigQuery syncing process. So I have all this stuff. I gotta refresh my memory here a little bit, but there's all this stuff around how we generate the schema. Yep. Okay, layer schema. Here you go. So we like fold through. This is this just like streams out of the database all of the property values for that layer. We fold through them, and in this case, we're just pulling, like I said, I said set of string because I'm just pulling the column names, just pulling the field names. And what I think I need to build out of this is basically build up a map of string, comma, set of JSON type. I guess I'll probably make an enum for that. So we'll build up something like all the observed types for each given field. So at the end of the day, we'll have something like, well, let's say this example we were looking at here. I'd have new num set of number or something, as like that's a JSON type. And then, I'd have like another one like pizza, love pizza, as set of string. And then the reason it has to be a set is because you could have, like, we're not enforcing a strict schema on the ingestion side yet, so it could have a variance. It could have like a mix. So you could have, the value new num for one row has number and the value new num for another thing has a string or whatever. And so then we're gonna have to like accumulate all of these, and then basically at the point of exporting the actual rows, we'll upcast them into some kind of common ancestor thing, which will probably just be, if there's any divergence, it'd probably just be a string is what it'll end up happening. All right, so let's see. So dot fold. Okay, yeah. So let's see. This will be. Let's see. How are we gonna represent this? I guess I'll do a sealed trait. JSON type. What do you have? You have JSON number. String. Oh wait, I guess I'll just put them in here. Object. JSON type. Yeah, okay, we can put them in here. Number, string, null, array, object, boolean. Are those the only ones? JSON. I've been doing so much JSON lately. I should really like just know this off the top of my head, but I don't. String, number, yeah, okay, I think we got them all. Okay, yes, that's good. So that's good. It'll be fold map string JSON type. Okie dokie. So, okay, this is going to be interesting. So I have here, this is the, what am I going to call this? Typeset typeset. It's kind of a weird name, but okay. So I have in here my new properties, and props is a JSON object in Cersei. Yo, what's up, CKIP? Welcome to the quiet morning here. Yeah, you got that. Oh wait, is this you're you're the guy who was talking recently about that like Scala tooling. Are you the like Scala tooling guy? I think I saw your post maybe somewhere about like a podcast you were gonna do or something. Am I mixing you up with somebody else? Let me pull this up. Yeah. Oh, that's so. I think I didn't comment on your thing, but I think that's a cool idea. If you do that, I would definitely. Yeah, this was it, right? Yeah, sick. You should definitely do this. I'm a fan. That's cool. Yeah, I'm actually. This is great. I'm using. Oh, you do it on Twitch? That would be cool. Yeah, do it on here. Yeah, the Twitch is fun, I guess, because people can ask questions and stuff. Yeah, I'm exactly right. I'm actually using Emacs, but I'm using Metals and all that stuff, and it's great. I'm a huge fan. I'm so glad that tool has become like a thing in the last couple of years. Yeah, well, I use Emacs and I use the evil mode thing, so I use like Vim mode in Emacs, so I'm kind of a blasphemer, I guess. But yeah, what was I gonna say? Yeah, I don't know. I think it's cool to see all that stuff. Oh, I remember. I was gonna say the yeah, Leafs room. Yeah. I really enjoyed I can't remember the guy's name, but the guy that that started that Scala Logs podcast. I've been enjoying that. That's like sort of comeback, so it's fun to, I don't know, it'd be cool to see more stuff around that in the scene. All right. What are we doing here? This music is getting weird. There we go. Something like that. What do you even have on here? So this is a Cersei JSON object. How do you filter keys, map values? I need to map. Oh, I just need to. To list. Yeah, okay. This is gonna be gnarly because this is gonna be like a fold within a fold, I guess. Let's just try it. Let's just see what we could do. Fold, type, set, case, key, val. Oh wait, no, sorry. What'll it be? It'll be comma, pair. That's annoying that you can't. I don't know if it's a way to destructure. If you have a fold like that, I don't think you can. Can you do like key and val here? No, I don't think you can. I think you just have to do like pair. All right. Okay. Oh yeah, okay. Object. I don't know. Def 4. Oh, you can't do 4. Def JSON type, whatever. I don't know. That's early. I'm having some name freezing here. Basically, what I need here is Cersei JSON. If, God, I've written this code or something like this so many times, is string else if Cersei.is. I'll just do them in order. Number else if Cersei.is null else if Cersei.is array. Right. I was like talking about this on stream the other day. Like, I don't know why. I feel like I read somewhere a long time ago a like rationale for why Cersei doesn't do an ADT for these things. So you have to do this like predicate by predicate, like if. I mean, not that it would be that different, because like I guess otherwise you would just be like, you know, Cersei match, you know, case blah, which is, it's not like that is necessarily any shorter, but it feels a little different somehow. I think there's, I don't know, some reason that they did it this way. Is object. Object. Let me. Should I put them in order? No, I'll just reorder this one. Okay. String, number, null, array, object, boolean. Else, I don't know. There's no, I mean, see, this is why the ADT would be good, I guess, because if you had the ADT, you wouldn't have to worry about this else, because like there's, you know that this can't happen, but yet you have to handle it. Because if you don't do this, I think the compiler yells at you because you're returning, you know, counts this as a unit or something. Yeah, that is. Yeah, I don't know. I would like to understand that, why it is designed like that. Fuck it, I'm just gonna put null. If it's something else, we're just gonna do something weird. I don't think this should ever happen. All right, that's cool. So pair. Okay, val JSON t equals. Oh yeah. I'll call it of instead of for. I guess I could do apply. I don't know. Fuck it. JSON type of v. Okay. Val set equals type set dot get. Oh no. Did I have this backward? No, that's right. Is that right? Nope, doesn't like that. Oh god. Oh no, it's probably unhappy about all kind of stuff that's happening down here. Let's just get rid of this for now. What's it think now? It thinks it's yellow. Okay, yellow better than red. Oops. Found equals. That is odd. Required. Found equals. Fold should be Z. Oh, right. I don't need fold. I need, because fold has to be the same. That's why it's upcasting that, right? I need fold left is what I need. Yeah, fold left is what I need. That I always get these mixed up. There we go. Now we're okay. So now typeset.get or else set and then basically I have to basically like I'm basically trying to fold through, and for each key I'm building up a set of all of the observed JSON types and like folding them in. So that's what I have to like do here. I don't know if I have to think. I could think about this. There might be a cleaner way, but this seems like it's okay. Set. How do you do that? You do set plus k. Let's see. This is set JSON type. I don't know how this yellow stuff. I turned on the like unused warning in my like compiler settings, and it's good, but the fact that it does this when you're like while you're in progress working on something, it's obviously not being used, so it highlights it, is a little bit annoying. I don't know a better thing for that. So you could do that, and then it's just going to be red. I don't know. Odd. All right. Anyway, we'll come back to that. Get or else. Oh yeah, get or else K. Required string. Found. Let's see, Scala add to set. How do you do that? Not plus equal. Plus, it is just plus. Yeah, okay. I need some annotations in here. Okay, I should actually, you know, to be honest, I should pull this out into like a new thing. Layer JSON types. And that'll be just this business here. This is getting more complicated. Ooh, it compiles, but what does it mean? JSON types. So that's going to be IO, so I'll map JSON types. I might need to type alias this. Okay, getting somewhere, getting somewhere. I did something funny with my braces. I think I missed a brace somewhere. Yeah, there we go. Maybe that's better. Yeah, okay. That's better. Okay, yeah, this is good. So because now basically what I need is I need a second. So this says pull out of my database. This is using Doobie. And so this is actually using like a Doobie to FS2 stream. So fold through for this layer that we're looking at. So that would be like all of the data for my one, you know, here's like maybe one layer in my map that I have. So I have fold through all my data, just the properties, sort of scan through them, pull up the schema, and generate like a map of a set of, for each key, all of the observed types. And then I have to turn those things into an expected BigQuery schema based on like, it's basically like some kind of common denominator situation, you know, or common ancestor, some kind of like upcasting thing. So BQ schema for JSON types. Okay, I've had it. I'm doing the alias. JSON type. JSON. What do I call this? JSON schema. I guess I'll say JSON schema equals this. Oh, wait. I said this should be set. Is that why my type stuff was going so haywire? Because I did it weird. Does this compile? No. Something is host. Oh yeah, well of course it's host because I did this. Unmatched closing brace. Oh, I screwed up my closing braces again somehow. Oh, which one? 133. Oh, that's why I screwed up. Yeah, okay. Okay. Okay, that's fine. I something I knew was like fishy down here when I was doing this, so. All right, what does it not like about that? Let me make this a little bigger. Okay, yeah, right. It's a stream, and then so you have to compile, run. What's the method to actually run it? I can't remember. Is it just compile? Oh, you have to. Yeah, you always have to get it to a sequence. This always trips me up a little bit. Like you always have to get it. Because if it's empty. So this will give you IO a vector of it'll give you IO a vector of like whatever your thing is, even though you did a fold, because it assumes that the fold. Yeah, this always trips me up a little bit. But it's okay. You can do. Yeah, I'll just put it here. Nice thing about immutable data is you can do this. Reuse that empty there. How about that? How about that? Okay, that'll do it. Yeah, that's a little bit of shenanigans there. That trips me up all the time actually. Like it's like you do an FS2 fold, and then the IO you get is a collection of what you folded, even though the fold should reduce it down to 1. But I don't know. That's how it goes. I'm sure there's some principled streaming reason as to why it has to be that way. Well, this is a little bit much here. This is nice. I'm trying out the like super chill piano station on Epidemic today, and it's a mix of some good stuff and some that's a little bit much, but all right, this is good. So here we go. Okay, so now JSON schema. BQ schema fro. BQ schema for JSON types. Oops. Okay, so now I'm going to need a bunch of this business down here. And I guess what we need is another one, BQ type for JSON types. This will be a set JSON type. And this will be interesting. I guess what I need out of this is legacy SQL type name. Okay, so this is the part that this is really like kind of the gist of the whole thing, I guess, is like you need, okay, so like what are the cases basically, right? You can have a single value, a single type. So let's say if it was all null, null is a special case, I'm just going to string, null is going to go to string. Num is going to go to, ooh, that's actually interesting because because fucking JSON, they could be floats or ints or whatever. Let me think about that. Does it have Circe.is number? It doesn't have a way to tell you if it's like a float or an int. Let's just say that. Okay, so yeah, that's interesting because at some point I might need to enhance this to make it not exactly mapping one-to-one to JSON, because I really want to map. What I'm really ultimately trying to do is map into the BigQuery types, and so I might want to make it like I might want to differentiate at least between number and float. Let me think about that. At least between between like int and float. BigQuery numeric or BigQuery legacy SQL type name. I would do integer, and I would do float is basically the ones that I would support. Let me see. How do you Cersei JSON number handling? So you can always to double if it's a valid Scala.long. What does this inherit from? Oh, this is abstract. What is the conditions for what is the conditions for valid? Optimization by cases. Can you show me what the subtypes are? So I guess you could basically do it. Okay, let's do it. So we're gonna have long and we're gonna have double. We're gonna have JSON long and JSON double. So if it is a number, it's a number. Okay, so we're gonna do his number, and we know we checked it, so we should be able to do it safely. Num.toLong. Let's see, is there something? No, there's not like an is valid long. If num.toLong. Okay, this is a little inefficient, but I like to basically box it and make it just to check it, but that's okay. If it can be longified, we'll do long. Else we will do double. Okay, so no, yeah, okay, so now we got it. Now we got it. So we'll have a double, double. We'll have a num long to big int or whatever. But I think BigQuery just calls it an int. Now for now, see with the nested stuff, like nested, I'm not gonna handle nested stuff for now. So if you have an object, it's just going to be a string. We're just going to JSON stringify it. And if you have an array, the same thing. We're just going to, because I'm not going to handle like recursively parsing these out for now. I just want to at least get like numbers and booleans. Those are the ones I care about for now. So those are fine. Now then the part that gets tricky is multi-type. And the answer is basically if there are more than one types. Well, okay, I think there's two cases. There's null plus one other type. That goes to that type. And then if there's null, or if there's non-null plus multiple, e.g. non-null plus string plus num, it's just always going to go to string because they can always be stringified, so the string is always going to win. That's going to be the deal here. Man, I should really I should really write some test cases for this is what I need to do. Yeah, I need to pull this out somehow. Can I put this up here? I don't really want to put it floating is the problem. Maybe. Well, is it valid to put this here? I think it is. This one is not valid to put there, sadly. All right, let's chill out for now, compiler. Yeah, this is This is what I need here. This is what I need to test. All right, that's good. This can just be plain old vanilla imunit. Don't even need anything fancy. What is this? BigQuery JSON type conversions test. All right, let's see. Can we test that? It looks like it didn't compile. Oh, assert equals is the imunit assertion method. Okay, okay, good. All right, good. Okay, so literally, I'm gonna have set of JSON type dot null. If I have just a null, it's gonna be legacy type name dot string. Because the other thing is, like, I think, yeah, I'm just gonna for now I'm just gonna always make them nullable. I don't know that there's that much benefit, honestly, to having the columns. Like, in theory, if you knew that they were never nullable in BigQuery, you could set it to be non-nullable. But or sorry, if we knew that they were never null in the data, we could set it to be a non-nullable in BigQuery. But I honestly don't know that there's that much benefit, and it makes things more complicated. So yeah, this is gonna be this. Okay. Good. String goes to string. Oops. Double goes to double, or float, I think is what they call it. Is that what I said it was? Float. 64-bit float, yeah. We don't have lower value floats, which is fine. Oh yeah, so these aren't even evaluated yet, or aren't even implemented. Cannot prove that legacy type. Oh yeah, what did I say? Oh my god, sorry, I didn't actually call the function. That's why. BQ type for JSON types. Okay. Sure, fine. Implementation is missing. Yeah, it is. Let's go. Let's fill it in. Can you match on this? Can you just straight up do like JSON T match case set JSON null? Oh, this is bad. Did I just do some weird import? Oh yeah, I just accidentally imported. This is the problem doing JSON stuff like this, is you end up with so many things that are like JSON blah on your class path. It's like such a disaster. Does this work? Like, can you literally match on things like literal sets like that? Equals, let's say you have set, let's see, A is set 1, B is set 1, 2, A match case set 1 matches. Oh yeah, set is not a case class, nor does it have an unapply. Okay, you're right, you can't do that. You just have to do a equal comparison, I guess. guess you just do them like this a bunch of times. Oh, this is vigorous. All right. And then my fallback, I guess, is just always going to be string for now. It's too bad you can't do the match. That would have been cool if that had worked. All right, there we go. Now we're moving. I guess I shouldn't allocate sets for this. All right, here's all the single cases. So if you have one and it has a string, it's string. If you have one and it has double, it's float. If you had one, it's Boolean. You get a Boolean. I guess what I can do is just move the string down. Well, whatever. Null, string, double, Boolean. How do you put this? You have the long. Integer is their big int, or their long, or whatever. If it's Boolean, else it's gonna be. So the only other options there is it could be the array and the object, and those are gonna have to be string. Okay, getting somewhere. Long goes to int. String. Null, string. So I think I hit all those cases. Okay. Now the multiple ones. Now the cases, is there ever... Okay, so the other case is if it's 2. If it has 2 and one of them and one of them is null. If it has 2 and one of them is null, then we get the one that's not null, and that becomes the type, basically. Oh yeah, so I can even pull this out. Yeah, okay, this is interesting. I can do it this way. This will be maybe a little bit shorter. Oh god, I just wrote all this out. Man, it is hard to code in the morning. Jeez. Okay, that's good. Double long, bool. Yeah, this is better. Double long, boolean. And then that's the leftover, okay. Because can you get just like the first one? Head, yeah, there we go. Why didn't it like that? Oh, yeah. Okay, that's good. Sorry, I gotta set up here. Okay, so now I need to, how do you remove it? JSON t dot without. Let's see, how do you, if you know it has a set of null and one other, how do you get the one that's not null? Let me think about that. Let me think about that while I get some coffee. Hold on. BRB. I'm going to take a quick coffee break.
Walk with me. Let's leave the past behind. Walk with me. There's something else we need to find. Say you'll go. Don't make me wait. There's no need to hesitate. Let's make footprints in
All right, back at it. Got Joe. Got warm Joe. All right, so I don't need this. What were we doing here? We were trying to figure out this JSON mess. E. So you could remove the null, or you could find. Maybe that's the easiest way. Yeah. BQ type 4. So get the non, if I know there's two and one of them is null, get the non-null one and do it that way. Else, so then this is the case I'm not 100% sure about, but basically, so this means that you have something like, you either have like string plus int, or you have null plus string plus int, or you just have like multiple. You have either you have a null and you have two or more others, or you have like n others. And basically, I think in those cases, it's always going to have to be string. Like there's not much else you can do there. Yeah. Okay. So I think it's just always going to have to be string, basically. But I'm going to have to run. I'm going to run through some test cases here and see if that kind of holds up to my expectations. Multis with null. So what this is going to be like is, let's see, how do I format this? So this one will still be string. This one will still be string. Like, then let's put a real one. Let's put like a double. Let's put a Boolean. Yeah, whatever. So I think this is fine. This works. And then you have the real multis, which I'll call like heterogeneous multi. So you'd have something like, you'd have like an array with an integer or something, or you'd have a string with wait, did I put, there's no integer, long. You'd have an array with a long, you'd have a string with a double, you know, whatever. You'd have an object with a string. You'd have a Boolean, a Boolean, a double, and a string. Walk into a bar. And it's just always going to be string in these cases. There we go. Okay. Okay, I think that actually is good. I think this handles what I needed to do there. At least for some bits of it. Getting somewhere. This is going to be kind of involved, basically, when we get all this stuff done. Starting on, what is it? Starting on JSON type to BQ type coercion logic. All right, all right, all right. That's cool. So that's, yeah, this is interesting. I guess I can clean this up now. Now, so now, okay, so now we can basically get now from we can go from a map of string set JSON type to map string legacy SQL type name, which is the BigQuery type. BQ fields. Yeah, so let's just do that. Equals JSON.map case k comma vals, and then I want, what was the one I called? Yeah, vals. So for each of those ones that we observed, we're gonna munge it through there and pull out the sort of single common ancestor, or the like optimal, I guess this is basically like the most specific BigQuery type, but it often will be a very unspecific BigQuery type. And then now we can actually make that into a schema. And then BQ fields. How do you, I need the rest of the code snippet here. How do you actually make you do schema of fields. Okay, that's how you do it. So you just like seekify this. Map case field name field type. So that'll be like, this will be string and then BigQuery SQL type name. Field.new builder field name and then the field type. Set mode is going to be always nullable, like we said. We're just not going to worry about that. And then you build it. So those would be our fields. And then you just do schema of fields. That's cool. That's cool. That'll work, actually. I think that'll work. Found. Oh, when you map it like this, you have to keep the key. You're mapping you're mapping the keys and the values. Is there like a map values or something? Oh, map values only gives you the values. Oh, I guess that's what I actually want here. I don't need the key. Yeah, okay, that's great. Vals. Yeah, map values is what I want there. Oh, and I don't need the case. Am I wrong about that? Oh, a map view. What is a map view? That's like some kind of lazy map iterator thing, I guess. Interesting. I thought there was some doc string that I saw in the Google results, but now I can't find it. All right, whatever. I'm just going to 2map it. I'm sure there's a 2map. It's a little bit not efficient, but screw it. Okay. Okay. Well, that's cool. And then here, this one's the IO. So the IO version is just calling into that. And that'll do it. I can even just do it sexy like. Yeah, okay. That is cool. Now we have, oh, I don't know why I put a random question mark there. Now we have plenty of other big problems though. Well, No, we have one more other big problem. Let's see. I feel like is something not compiling. Okay, it compiles. It compiles, but what does it mean? Okay, finish BQ dynamic schema generation logic. Okay, so that's good. So now the big problem is going to be on the actual export side. Basically, like we have generated this observed schema. We've generated an observed schema of what we think the best representation of our assortment of JSON types in a BigQuery schema can be. And now as we fold through as we map through and actually export, so here's the actual exporting, which is, the way this works is you actually have to, you basically export it we're exporting from the database to Google Cloud Storage, and then from Google Cloud Storage we load it into BigQuery by like starting a job. And so, let's see, valid props. Oh yeah, see, this is actually even, since I changed this the other day, is actually a little bad. Oh yeah, I always stringified. This is what I did. I said, yeah, this is good. This map string is actually not, like, this has to be changed. Has to now take in, so before we had JSON object map string, because we're always, the keys are obviously strings, but we were also always stringifying the values. So that's what the v.no space is. This is a JSON value and we're stringifying it. So now we have to take in also a BQ schema. And coerce things best we can. And I'm not, I'm gonna get this wired up and see if I can make it work. At some point I should come back and think about, like, if there's a better way to, there might be a better way to somehow like combine these things and like sequence them. I don't know. But basically, I might be losing information if you go like JSON to JSON schema to BigQuery thing. Sorry, I was just thinking out loud here. Basically, the question is like, this has to take schema, and the question is, should schema be like schema as in the BigQuery schema type, Google Cloud BigQuery, or should it be the one that I was using, JSON schema, which is just that's a type alias for map of string to set of blah, blah, blah. And I'm not 100% sure about that one. Let me think on this. Think about this. Well, I guess one thing we can do is we can make this, we can simplify this a little bit, because really the problem here is actually JSON value given a JSON, a Cersei JSON value, which will be our property, our value, not our key, but our value, and a schema. Oh, sorry, this is just schema. What we need to get out of this is a JSON value, another JSON value, which is kind of complicated, but that is what we need to do. Oh, sorry, I said not schema, but it has to be a field. Yeah, it's field by field at this point, which is why this is good. It's simpler. So basically we shouldn't have cases where they mismatch because of the way that we just did the previous logic. Like, we should be sure that we should be confident they're always going to match. But if we don't, for safety, we probably want to handle that without like blowing up, I guess. Or I guess we could just coerce it through and see. Okay. Field dot get type match. Okay, so let's do the easy one first. If it's a string, then it's easy because we just go no spaces. If it's a the ones. Okay, actually, really, let's do the other way around. Because if no space is obviously the fallback, string is the fallback. If it is anything other than that, yeah, okay. So the ones I have to worry about are basically these three. These are the only three that are going to get special attention. So this is actually not so gnarly because there's not so many cases, luckily. If it is a float, then we will do JSON.get JSON.asNumber.map. Oh yeah, that's okay. Then it's just JSON as number get or else JSON null. How do you get a Cersei null? Okay, JSON.null. Is there something special to float? To float? No. As JSON. Yeah, okay. I'm not decoding it. So if I think it's a float, then we'll float it or null. So that would handle the case where the get or the as number would handle the case where somehow we did it wrong and got that we thought it was supposed to be a float, but there was like a badly formatted thing in there or something. I don't know. Yeah, these are great. Okay, this is good. As we can just do this for everyone because they're always going to be nullable. So it's like if it's a type that we think we should handle, we try to coerce it to that, and if we can't, we just say null. And then this one, yeah, we're going to put a little filter on there. Too long. Yeah. Oh, yep. And then this one. Okay, yeah. So this is good because actually, yep, I actually have to hoist the others. I have to stringify the other ones. Yeah, this is good. So basically, like if it is a string, JSON, else. Yeah, this is the part that's going to be. This is the part that's a little screwy. Is like we're going to like nest them. We're gonna pre-stringify the JSON and nest it, so it's going to be a JSON string of a JSON. JSON.fromString, JSON.no spaces. There it is. So this says like if it was like 1, 2, 3, then we will make this into JSON.fromString 1, 2, 3, like the stringified version of that, which is what I want for now. Like in the future, we would ideally handle those in a real way, but for now, that's okay. What did I do wrong here? Oh, yep. Oh, so these one. Okay, this is because the as number gives you JSON number. So maybe this should just be handled the same way as like a if-else situation. Yeah, okay, that's good. I don't want like an option get or else. I just want an if situation. There we go. That's kind of gnarly. There we go. Need that. Okay. If it is a number and it is a valid JSON long, that's a little bit redundant to check both, but whatever. Let's just do it. If it's that, JSON else JSON.null. Yeah, okay, this is super nasty, but this is actually, I think, pretty much what we want. So as we, I'm going to move this down next to where we're going to use it. So when we export a layer as we fold through, we have to replace this. Oh yeah, where's my valid props? I have some other stuff where we're filtering out. Oh hell, I'm going to move all this stuff down. I should split this up, move some code around later, but whatever. Yeah, okay. Yeah, okay. Okay. Schema. This is actually going to give us JSON object. And what we have to do here. So there's some other stuff there's some other stuff about filtering out, like certain field names aren't allowed or whatever, so we filter those out. Now we're mapping over our JSON object. We're keeping the keys, and we're going to transform the values using that logic that we just defined. So how do we get schema.get? You can't get a specific field? That's annoying. Okay. Okay, let's fields map string field. Okay, I'll do it that way. Export layer. Valid props. Map. You'd say, oh, we don't even have the schema here. Okay. I have to pass that through. Oh god. So yeah, see, this is the I'm gonna have to reorder some of the orderings here. That's a little bit annoying. That's okay. So I have to get my schemas. Zip schemas. Yeah, there we go. Layer schema. Because previously I was able to do those completely independently because the dumping of the data was not dependent on the observed schema in the database, but now it actually is, and so that's what all this is doing. Now I got all kind of situations I will have to deal with here. What do you get name and F map. Oh boy, wiring shit up. Wiring everything up. This is getting deep. That's okay. Val field equals this is going to be kind of weird. Like, I guess I'll handle this. If there was one in there that was not if there was one in there that wasn't known, that shouldn't happen, but what would you do if there was a field in there that wasn't known? I think what I would just do is I would just omit it, honestly. We'll just omit it. There we go. Value. There we go. Wait, can you do a map values? Oh, you need the keys, though. You can't do a map values because you need the keys. Ooh, okay, so I actually thought that was going to compile. Found. Oh, props. Value map is not. You have map values. You have You don't have a map on JSON object. Interesting. Okay, so you have to keep it how I had it to map. This is going to be a map. This is going to be transformed. Props is going to be map string JSON. Can you splat a map? No, you can splat a seek. Oh boy, okay, that'll do it. Oh, compiles. Wow. Damn, it's almost 9. Big doozy there. Is it possible that this works? That would just be insane. There's like almost no possible way. But maybe I'm going to use my last 5 minutes to run this and see if it crashes. And I will be astonished if it does not crash. But you know what? Let's give it a go. So I can come in here, sync it. It's running. Ah, failed. Yeah, okay. I don't know what I was expecting, but Is there any logging out of that or something? Failed. Could not start. Could not convert value number value 5.0 to integer. Oh, that's interesting. That's interesting. It might be the case that the fact that this says 5.0 is odd. It makes me wonder if, well, it's a string of 5.0. Yeah, okay, I don't know. Something about my logic obviously is not quite right. I'll have to dig into that. I don't have time for it right now, but I think it's getting close. We're getting there. This is kind of a complicated thing to munge around, but we're getting somewhere. Oh boy, oh boy. Okay, another step toward genuine BQ types. Not quite working. Some number stringification is off in my example, but getting there. All right, cool. That's gonna have to be it for today. Quick short morning situation. Yeah, this is kind of fun. This is kind of interesting. It'll be cool when this works. What I was speculating about is I wonder if like the Cersei long check that I was using, it's possible that doesn't work the way that I think, because I like, it's possible that even if it knows that it is a JSON number that could be represented as a long, that it might still stringify it with the decimal, which would be like not super ideal for me. I'm just gonna have to get into the weeds of how like BigQuery handles the nuances of that. Like if you tell BigQuery that it's an integer, but you give it a 5.0, is it okay with that? I'm not sure. And then also it looks like in this case I'm giving it a string anyway. So that's not good, obviously. But yeah, okay, cool. All right, I gotta run. But thanks to anybody who stopped by today. Have a good Tuesday, everyone. See y'all.